This is 14.3 Part 1, Geometric Sequences in Series, and your objectives are all listed here, but we're going to really concentrate on the first three in Part 1. That is, find the common ratio of geometric sequence, write the terms of a geometric sequence, and use the formula for the general term for a geometric sequence. So, let's look at the definition of a geometric sequence. Geometric sequence is a sequence in which each term after the first obtained by multiplying the preceding term by the fixed non-zero constant. The amount by which we multiply each time is called the common ratio of the sequence. So, like in our arithmetic sequences where we're adding something each time, this time we're going to be multiplying by a common ratio each time. So let's look at example 1. It says, writing the terms of a geometric sequence. Write the first 6 terms of a geometric sequence with the first term 6 and a common ratio of 1/3. So I want a sub 1, that's my first term, that's 6. A sub 2 is now, we've got to multiply by our common ratio. We take that 6 and multiply by our common ratio. So it's 6 times 1/3, which is 6/3, or 2. A3 is now to take A2, which is 2 times our common ratio. 2 times 1/3, that would be 2/3. A4, that is take the A3, which is 2/3, multiply it by 1/3, that's our common ratio. If I can draw 3, that would help. There we go. 2/3 times 1/3, that is 2/9. A5, that would be 2/9 times 1/3, and that would be 2/27. And A6 is 2/27 times 1/3, that is 2/81. And those are the first 6 terms of this problem. So you got 6, 2, 2/3, 2/9, 2/27, 2/81. Your job is to do the checkpoint. So press pause here, make sure you're showing your work on all the checkpoint, and then I will give you the answer. So the answer for the checkpoint 1 is 12, 6, 3, 3/2, 3/4, and 3/8. Let's look at page 2. You have the general term up at the top here of a geometric sequence. This is, we can find any term we want in a geometric sequence by this formula right here. A sub n equals A1 times r to the n minus 1. So say we wanted to find the 10th term, it would be A sub 10 would be equal to the first term times the common ratio, that's r, raised to the 10 minus 1, because n would be 10. So let's do an example. Example 2 here. Find the 8th term of a geometric sequence whose first term is -4. So that is our A1. A1 is -4. And the common ratio is -2, so that's our r. So we have our formula. We want to find, well, A sub n equals A1 r to the n minus 1. We want to find A sub 8 because that's the 8th term, that's what we want to find. A sub 1 we know is -4. R we know is -2. And n minus 1, n is 8, so it'll be raised to the 8 minus 1, which is the same as negative 4 times negative 2 to the 7th. And negative 2 to the 7th is a negative 128. Don't multiply the negative 4 and the negative 2 first. You got to do the powers first because of our order of operations. So we get negative 128 times negative 4, and that comes out to 512. Oops, screwed that up. 512. So your job now is to press pause, do the work on the checkpoint, and when you're done, press play again, and I'll give you the answer. So, our answer for the checkpoint 2 is, we wanted a sub 7, that is negative 3,645 for checkpoint 2. Let's look at example 3. Move it up here. It says the table shows the population of the United States in 2000 with estimates given by the Census Bureau for 2001 through 2006. That's what this says up here. And then you have the table with all the numbers here. A says show that the population is increasing geometrically. B says write the general term of the geometric sequence modeling the population of the United States in millions n years after 1999. And C is project the U.S. population in millions for the year 2009. So to show that something is increasing geometrically right here for A, what you do is you take two consecutive numbers and you divide them. You divide a number by the number that precedes it, so the number before it. So we're going to take 284.5, so this is part A, 284.5, and divide by the number in front of it, 281.4, and we're going to get approximately 1.011. Now to check to see if we have a common ratio, we got to take two more numbers and figure out if those two come out with the same answer, 1.011, the same ratio. So we got 287.6, and the number that precedes that is 284.5, and that comes out to 1.011. So we know our common ratio is 1.011, and if you have the same ratio as you go through, then you have a geometric, problem is increasing geometrically. Sorry. So let's look at B. For B, we got write the general term for the geometric sequence modeling the population of the United States in millions of years. So you have the formula above with the general term. That's the A sub n formula for a geometric sequence would be A1 times R to the n minus 1. And we're going to plug in what we know, and we just want the nth term, so we don't know what n is yet, but we do know the first term is 281.4. And we know the common ratio we just found in part A, that's 1.011. We don't know n, so it's raised to the n minus 1, and there's part B, that's our general term. Part C says project the U.S. population in millions for the year 2009. So C, if we want to know what n is, what term we're talking about, we know this thing starts in 1999, and we want to project to 2009. It's easy to get the answer of what n is, if you just take the 2 and you subtract them, which is pretty simple, 2009 minus 1999 is 10 years, or n will be 10. So we're just going to try and find the 10th term, a sub 10. Put it into our general formula, which is 281.4 times 1.011 to the 10 minus 1. And if you multiply and raise to the 9th power and do all that out, you come up with 310.5 million people in the year 2009. So that's the projected population of the United States in 2009. You are going to turn to page 3, and you will do checkpoint 3. Press pause now, and then do checkpoint 3, and when you come back, I will give you the answer. So the checkpoint 3 has a general formula. Oops, get my pen out here. Of a sub n equals 3 times 2 to the n minus 1. And it said to find the 8th term, so a sub 8 is going to be 384. Make sure you're showing your work on your checkpoints. Having just the answers will not get you full credit. And that is the end of 14.3 part 1. We will pick up for part 2, starting right with the sum of the first two n terms. You'll pick that up in the next video.